graphing harder trigonometric functions. So in our last video, we looked at graphing some basic trigonometric functions. And let's just do a little recap. So we had y equals sine x, y equals cos x, and y equals tan x. And the amplitude of this one was 1, and the period was 360 degrees. Amplitude of cos graph was 1, also with a period of 360 degrees. Tan had no amplitude and a period of 180 degrees. Now, we need to look at more generic cases. So we're going to look at y equals a sine bx, y equals a cos bx, and y equals a tan bx. So if this is the case, our amplitude of this graph is actually equal to a. So if a is equal to 3, that's our amplitude. And our period equals our original period of 360 divided by the value of b. Same goes for cos. So our amplitude would be a, and our period would be 360 divided by b. Again, for tan we have no amplitude, so that value of a doesn't matter too much. It would just change the steepness of the curve. And the period for tan would be our original period, 180, divided by b. So how can we apply all of these to graphing some harder functions? Let's have a look at some. So let's have a look at y equals 3 sine x. So we've got to use our knowledge of our basic functions in order to graph these. So we've got our xy axis, and every graph I'm going to do in this video is going to be between, x is going to be between 0 and 360. So the only thing that's changed from our basic function, we've got this extra 3 here. And remember, the number in front of a sine or cos function is going to change its amplitude. So normally we'd have our function starting from 0, coming up to 1, and down to -1, and stopping at 360. But because it's now 3, we've got our graph going up and down. So the same way, but it's in between 3 and -3 in this case. And we should show our x-intercepts, so 360 and 180 there. What about y equals minus cos x? We're just using a simple graph transformation. We know if you put a negative out the front of any function, it flips it about the x-axis. So normally, we start at 1 and we come down and then back up. So if we're flipping it about the x-axis, instead of starting at 1, we're going to be starting at -1. So we get something like that, where we're starting at -1, goes up to 1, and that's our 360, which means that's 270, and that's 90, with the middle there being 180. Now it can get a little tricky when we change the period. So let's look at y equals sine 2x. So our period for sine and cos is 360 divided by the coefficient of x, in this case is 2, so we get 180 degrees. And what this means is that it's going to take 180 degrees for one complete cycle of the graph. So if we're graphing between 0 and 360 and a period's 180, we're going to get 2 full cycles in. And a nice way to think about it is pretty much whatever the coefficient is here is how many cycles or periods you're going to fit in between your 0 and 360. So let's have a look. So the amplitude hasn't changed, and we're still going to start from 0 and go upwards because it's positive. But this time, when I do one period, the period's 180. So a complete cycle doesn't go to 360, it goes to 180. So if we're graphing between 0 and 360, we need to do another complete cycle. So another cycle gets us to 360. So that would be 270, and that would be 90, and we're going between -1 and 1. Alright, let's have a look at an even tougher example. So minus cos a half x plus 1. So we've got a few things to deal with in this one. We've got this negative, which is going to flip it about the x-axis. So instead of starting at 1, it would start at -1. We've also got the +1 on the end, which is going to shift the graph up 1. And we've also got the half in front of x, which means we're only going to be showing half a period for 0 to 360. So let's see if we can put all that together. So this negative means we'd start at the bottom at -1, but because of this +1, instead of starting at -1, we're going to start at 0. There's going to be an upside down graph because of that negative, and we're going to be starting at 0. So we're just going to indicate that. So we've actually accounted for the negative because it's going upside down, and we've accounted for the +1 because instead of starting at -1, we're starting at 0. So normally this graph would go between -1 and 1, so everything gets shifted up 1, so we're starting at 0, so it'll be between 0 and 2. Because you can think about the end is at 0, so the middle, because we haven't changed the amplitude, so the middle is going to be at 1 and the end of the graph is going to be at 2. Now, between 0 and 360, we're showing half a period. So I'm going to draw a complete one in. So a complete cos cycle would look like that. And if we only want to show half a period to get to 360, that means half of the period is actually going to get us to 360, and we're not going to need any of the rest of the graph, so we can actually rub all that out. And that's actually going to be our final answer for the graph. What about y equals -3 tan 2x? Okay, so remember, minus means we're going to flip it upside down. The 3 for a tan function doesn't change too much, it just changes the steepness, but we don't really have to show that when we're doing a sketch. And the 2 here changes the period. So because it's 2x, we're showing 2 periods for 360. Actually, because it's periods 180, let's just write it out. So we know our period for a tan graph is going to be 180 divided by the coefficient of x, which is 2. So we're going to get 90 degrees. So we know every 90 degrees we're going to get one complete cycle of the tan graph. So let's draw this out. Alright, so normally the tan graph starts at 0 and goes up, but because we've got a negative, we've got to go in the reverse direction. So we're going down. And we know its period is 90. So if you think about on this side, we don't have to draw this, but I'm going to draw it in just to make it obvious. This is one period, and this should be a distance of 90, which means half of this is going to be 45. Because that would go to minus 45, and that'd give us a period of 90. But we don't have to draw any of that, because we're only drawing from 0 to 360, but that was just so we could see what was going on. And now we can keep drawing our tan graph in, knowing that we're getting 90 every time with a period. So that would get us to 135. Another 90 would get us to 225. Another 90 to 315. A bit more room. And we've only got 45 left, so we're only going to draw in half a tan graph, and that'll get us to 360. We're going to look at one more graph, just y equals sine of x minus 90. Now, if you know your graph transformations, you'll know when you have a bracket and x minus a constant or plus a constant, this is what will shift the graph left or right. Now when we minus something, we're actually shifting it to the right. So nothing else has changed for our sine function, and normally our sine function starts from 0, goes up and down and finishes at 360, but minus 90 would shift it to the right by 90. So you can think about the start, instead of starting at 0 like the end, we're going to start it at 90 and go up. So let's do that. Go up and down. This is starting at 90. And remember, this distance here is 90. So that means that part will have to come in there. So we're actually starting at -1. And we only want to draw up to 360. So that's 180. That's 270. And there would be 360. So the rest of the graph is not needed. And that would be our answer for that one.